College of Technology, Department of Mathematics. In this lecture video series Statistical Data Representation, we are going to see understanding frequency distribution, cumulative and relative frequencies in this video. So this is to discover how to organize, analyze, interpret data patterns through the powerful lens of frequency distribution. From basic concepts to advanced applications, we'll explore the essential tools that transform raw numbers into meaningful insights. So first, let us see what is frequency distribution. A frequency distribution is a statistical tool that organizes data values by counting how often each value or range of values occur in a dataset. This systematic approach transforms chaotic raw data into organized, interpretable information that reveals underlying patterns and trends. Think of it as ascertaining order from chaos instead of looking at hundreds of individual data points. We group them into meaningful categories and count occurrences. This process makes large data sets manageable and helps identify the most common values, outliers, and overall data structures. So here is the example. For when measuring the children height in a classroom, we might find the most children fall within a certain height ranges, creating a clear distribution pattern that help us understand the typical height characteristics of the group. Now let us see the types of frequency distributions. Those are ungrouped, grouped, relative and cumulative. So they record the frequency of individuals, distant values from discrete data like the number of pets owned by families or shoe size in a store inventory. So for example, counting exactly how many students have 0, 1, 2 or 3 pets. So next is a grouped data in which this organizes continuous data into class intervals or ranges, essential for managing large data sets where individual values could create too many categories. Example, grouping ages into ranges between 10 to 14, 15 to 19, 20 to 24 years. So next is a relative frequency which shows the proportion or percentage each category represents of the total dataset, enables meaningful comparisons between different size groups. Example, 35% of survived customers prefer online shopping over in store purchases. So next one is a cumulative frequency in which represents the running total of frequencies up to and including each category reveals how data accumulates across the distribution. For example, 150 students scored 80 or below on the examination. Next is visualizing frequency distributions. So visual representation transform numerical frequency data into intuitively easy to understand formats. So the choice of visualization depends on your data type and the story you want to tell. So here the first diagram shows the histogram and the second one the bar chart. Next, understanding relative frequency. The relative frequency transforms raw counts into proportions, making data interpretation more meaningful and enabling fair comparisons between data sets of different sizes. So the next one is calculate the formula. So relative frequency is equal to frequency divided by total number of observations. Next, express as percentage, so which converts decimal to percentage by multiplying by 100. This makes results more intuitive and easier to communicate to others. The next one is enable fair comparisons. So this compares data sets regardlessly of their original sizes. A group of 50 people and a group of 500 people can now be meaningfully compared using percentages. The next is understanding cumulative frequency. Previously we have seen relative frequency. Here we are going to see the cumulative frequency. So cumulative frequency represents the running total of frequencies, showing how many observations fall at or below each class boundary. So this powerful tool helps identify key statistical measures like medians, quartiles and percentiles. So unlike simple frequencies which tell us about individual categories, cumulative frequencies reveals the accumulation pattern across the entire distribution. It answers Questions like how many students score 75 or below, or what percentage of customers spend less than $100. This concept is fundamental for understanding data, position, and creating percentile rankings that are crucial in educational testing, business analytics, and research applications. So now let us see an example in which both relative and cumulative frequencies are applied. Here the height ranges are given in a continuous range, which is 120 to less than 130. Next is 130 to less than 140, or 140 to 150, 150 to 160, 160 to 170. So here the frequencies are 9, 10, 13, 11 and 7. So the relative frequency corresponding to the first group is 18% and the cumulative frequency is 9. Then the relative frequency corresponding to the second one is 10 by which value gives the 20, and the cumulative is 9 plus 10, which is 12. On calculating for 140, 150 and 160 ranges, we get 26, 32, 22% and 43, 14% and 50%. So finally the cumulative percentages are given in the last column. This table reveals that the most common height range is 140 to 150, which means that 26% students falls under that category, while 64% of the children are shorter than 150 centimeter. So therefore the cumulative column helps identify the median height falls within the 140 to 150 centimeter range. The next is step-by-step calculation of the cumulative frequency. Start with first class. So there the first one is 9. To the next frequency we can find it by 9 plus 10, which is 19. On concluding, we could get the total number of frequencies as 50. Next is why use relative and cumulative frequencies. So the proportionate importance. Relative frequencies reveal the true significance of each category within data set. Instead of being misled by raw numbers, you understand what percentage each group represents, enabling better decision making and resource allocation. Next is statistical measures. So cumulative frequencies are essential for identifying key statistical measures like medians, quartiles, percentiles. These measures help you understand where individual data points rank within the overall distribution. Next is dataset comparisons. So both a relative and a cumulative frequency enables meaningful comparison between datasets of vastly different sizes. So compare customer satisfaction between a small local business and a multinational corporation using the same percentage-based metrics. Next is trend analysis. Using understanding frequency patterns helps identify emerging trends, seasonal variations and long-term changes in your data. These insights drive strategic planning and operational involvements across various industries. The next is visual example. So the cumulative frequency graph is otherwise called as OHI, which is pronounced as O-Xi. Is a specialized line graph that plots cumulative frequency against class boundaries, creating a smooth curve that reveals the accumulation pattern of your data. So here how to read an OHI. X-axis represents class boundaries, y-axis cumulative frequency. Then the curve always rises from left to right. Next deeper section indicate higher frequency and the final point equals your total sample size. So here are the practical applications. So in educational sector, schools use frequency distribution to analyze test score patterns, identifying learning gaps and track students' progress over time. Next, cumulative frequencies help determine grade boundaries and percentile rankings for college admissions. Next, in business analytics, companies analyze customer purchase amount, website traffic patterns, and sales performance using frequency distributions. In healthcare, it is used to monitor patients' age distribution, symptom frequencies, and treatment outcomes. In quality control, manufacturing companies use frequency distributions to monitor product specification, defect rates, and process variations. This statistical approach ensures consistent quality and identify area for improvement. Next is your journey forward. So master the fundamentals. The frequency distribution organizes chaotic data into meaningful patterns. Relative frequencies show proportions. So how to apply tools? Start implementing this concept in your daily work, whether analyzing sales data or survey responses. This will be helpful. Next, transform your data analysis. These statistical tools empower you to move beyond simple, continuing, sophisticated pattern recognition. Every data set tells a story. Frequency distribution help you read the story clearly and confidently. Thank you.